In today's video, we're joined by infamous French mathematician Pierre de Fermat. He's asking us, what is the smallest number which 1008 would need to be multiplied by to give a square number? The trick to these sort of questions lies in prime factorization. So what we need to do first of all is find the prime factorization of 1008. Let's do that then. So 1008. Straight away we can see we've got a factor of 2 to take out. So let's take out a factor of 2 and we'll have 504, which we can again take out a factor of 2 from. Take out 2 and we're going to get 252 for the other factor, because 2 times 252 will give us 504. 252 can again split into a 2 and 126. Again, we can take out a factor of 2 for 126 and we'll get 63. Now we've got something that we can't take 2's out of, but we can take out a 9 and a 7. I'm running out of space a bit, but 9 can go into 3 and 3. I'll put them on there. So looking back at the end then, 1008, we can write its prime factorization like this. We've got some powers of 2, we've got some powers of 3, and we've got some powers of 7. How many have we got of each? Well, we've got 1, 2, 3, 4 powers of 2. Powers of 3, we've got 2 of those. And powers of 7, we've just got the 1. That's some really important work then that we've done. We found 1008 is 2 to the power of 4 times 3 to the power of 2 times 7 to the power of 1. Well, what's really important is for a number to be a square number, each of these prime factors must also itself make a square number. And what I mean is that 2 to the power of whatever we've got must make a square, 3 to the power of whatever we've got must make a square, and 7 to the power of whatever we've got must make a square. A square number has to have an even power. That's because when we split it up into 2 smaller numbers, its square root, we have to be able to split the power into 2 even groups. So what we need is this number to be even. The 4, that works. This number to be even, the 2, that also works. But the 7, not an even number. So to make our 1008 times something a square, we need it to be, our 2 can still be to the power of 4, that works. Our 3 can still be to the power of 2, that works. But we would need 7 to be to the power of the next even number above it. So at the moment it's power of 1. We need to have times 7 to the power of 2, because that means we can split our number into 2 to the power of 2 times 3 to the power of 1 times 7 to the power of 1, all of that squared. This gives us a square number. So what we needed to do was add on 1 more power of 7. And I'm going to write that in a different colour to show what have we changed from this number at the top, 1008. Well, we had to times it by another power of 7. And when we did that, we then had each of the 3 index powers as an even number. Just considering then, well, what actually is this number? Well, 2 to the power of 2 is 4, times 3 would be 12, times 7 would be 84. So what we've got here is 84 squared. In other words, the smallest number that we need to times 1008 by to get a square number is 7, and when we do that, the answer is 84 squared. The approach is very similar. First, we need to factorise 720 into its prime factors. So let's go for that first. 720. We're going to factorise it as 60 and 12. 12 can go into 4 and 3. And 4 into 2 and 2. 60 into 6 and 10. Which goes into 5 and 2 and 3 and 2. So then when we write the prime factorisation in full of 720, we're going to get this. So 720 is 2 to the power of 1, 2, 3, 4. 2 to the power of 4. We've got 3 to the power of 2. It's multiplied by 3 to the power of 2. And we've also got 1 power of 5. So times 5 to the power of 1. This is our 720. Well, what we need to do to get a cube number is we would like all of the powers in the prime factorisation to be multiples of 3. And that's because for a cube number, we'd like to split those powers up into even parts. So if it was 4 at the moment, that doesn't split into 3 even parts. So it doesn't work as a cube number. To turn our number into a cube number then, so I'm going to write this arrow, this is us turning it into a cube number. We still need to keep some 2 to the power of something. So we would like 2 to the power of something, 3 to the power of something, and 5 to the power of something. And all of those need to be multiples of 3. The next multiple of 3 above 4, well, it has to be 6, doesn't it? The next multiple of 3 above 2 for 3's, that's just going to be 3. And the next multiple of 3 above 1 is also 3. What this means is that this number here is now a cube number. 2 to the power of 6 times 3 to the power of 3 times 5 to the power of 3. And before we think about our missing number here, let's think about what this actually is as a cube number. So thinking about that, well, when we split this into 3 even parts, we get 2 to the power of 2, because that's 6 divided by 3, multiplied by 3 to the power of 1, 3 divided by 3, multiplied by 5 to the power of 1, so it's 3 divided by 3, and all of this is cubed. We'll keep on our thinking. 2 to the power of 2 is 4, times 3 is 12, times 5 is 60, so this number is 60 cubed. So that is the cube number that we'll get when we multiply 720 by something. It is actually a cube number. What we'd like to finish off with though is thinking, what was this number that took us from here to here? Well, thinking about what we've changed, our powers of 2 have gone from 4 to 6, so we added 2 powers of 2. Our powers of 3 went from 2 to 3, so we've added a 3 to the power of 1. And our powers of 5 went from 1 to 3, so we've added a 5 to the power of 2. And sorting those powers out, 2 to the power of 2 is 4, times by 3, 5 to the power of 2 is 25, 4 times 3 is 12, times 25, this would give us a times 300. So those were the two numbers we were looking for. When you times 720 by 300, that gets you a cube number. It's the smallest possible cube number because we only went up to the next multiple of 3 with each of the powers, and that number is 60 cubed.